In this example, we need to differentiate the product of this function given by secant theta times tangent theta. So how can we do this one? So you can notice here that this function of theta is given as product of secant theta with the tangent theta, right? So to differentiate or to find the derivative of the function f with respect to theta, we can just use the product rule. If you are not sure what product rule means, please revisit the product rule. Otherwise, let's try to apply that, okay? So how can we apply the product rule? So if we have a product of two functions, what can we do? We write down this first function as it is, which is secant theta here, right? So write that down, but multiply by the derivative of the second function, which is given here as, let's say, the tangent theta. If you don't like the first and second, okay, whatever is the next function, okay, you can use that, but leave one function as it is, multiply by the derivative of the another function. So let's say here tangent theta, okay? But that's not only the case, right? We need to add then what is the expression we need to add? We need to now multiply, we need to write down the derivative of the one of the function which we have not differentiated earlier, so which is here now secant theta, right? Earlier we have differentiate, or we try to differentiate tangent theta, we have not differentiated secant theta, so write that down, multiply by the second function or the another function as it is. So each time we are just differentiating one of the function and then, right, leave the other another function as it is and then adding them together. So this is how the product rule works. So on this particular step, I have just applied the product rule. If you are not sure what I have done here, please rewatch this video up to this point, or again, go to the product rule and then make sure that you understand that, right? So as a summary, I can just say here to use the product rule. If you have a product of the two function, then we leave one function as it is, multiply by the derivative of the another function, plus we find the derivative of the, for let's say the first function, multiply by the second function as it is. So that's what the product rule is. Once you are correct on this step, then we apply the product rule, but still we need to, it's still left over to differentiate, right, this tangent theta and then secant theta. We said we will differentiate, but we have not done that, so let's try to use the rule to find the derivative of that. So secant theta is as it is, right? So that's what we have over here, and multiply by the derivative of the tangent theta. What is the derivative of the tangent theta? Secant square theta, right? So that's the formula, so we can write down that secant square theta, plus now we need to find the derivative of the secant theta. What is the derivative of the secant theta? Okay, do you want to look into some rule? Okay, what is the derivative of the secant theta? Secant theta times tangent theta, right? So that is the derivative of the secant theta. Multiply by the tangent theta, right? Multiply by here the tangent theta as it is. So we just copy that. So you might have noticed we just whatever is the secant theta, we leave that as it is, multiply by the derivative of the secant square theta, right, plus derivative of the secant theta, which is secant theta times tangent theta, multiply by the tangent theta as it is. So that's what we have done. It's done. This is the derivative. But if you want to combine or simplify, let's try to see if we can do further. On the first term, we can multiply secant here. We can multiply secant theta with the secant square theta, right? So we then get secant cube theta. We can also write that in that way, plus on the second term, we have secant theta times tangent theta multiplied by tangent theta. So if we multiply them together, secant theta is as it is, but tangent theta times tangent theta can be written as tangent square theta. Okay, this is also done. But if you want to write down on some alternative form, let's say if you wanna take the, let's say here I can see secant theta is a common factor, I can take that out. So if I do that, secant square theta is the remainder on the first term, and then tangent square theta is the remainder on the second term. So that could be also another alternative. Well, if you want another alternative, do we have some? Can we? I think yes. Here we know that one of the trig identity actually secant square theta minus tangent square theta is equal to 1. Right, so this is the trig identity we have, right? So trigonometric identity. Now what that means is actually if you want to write down everything in terms of secant in terms of the tangent, we can do this as add tangent square theta on the both sides. So we can do this 1 secant square theta. Instead of that, we can write down 1 plus tangent square theta. Or from here, if we want to like a solve for tangent square theta, we get what do we get here? This will be equal to secant square theta minus 1. Right, if you add tangent square theta on the both side and subtract 1 on the both sides, that's what we get. So if you want to use those trig identity over here and then use like write down the answer in some other alternative, you can do that. For example, if you just want to use this trig identity over here instead of secant square theta, right, we can, if you use this identity over here, this will be written as, this can be written as 1 plus tangent square theta plus the second term is as it is, so this can be written as tangent square theta. So we can also change this one into secant theta times 1 plus 2 times tangent square theta. Okay, for example, if you didn't, I mean, for maybe you don't want these alternative expression, then if you are happy with this expression, this is fine. If you are happy with this, that's also fine. If you are happy even on this step, I mean, that's also fine. Or let's say if you want to change everything in terms of the secant, then after this, I mean, what we can also do is secant theta times what do we have here? You can see here tangent theta is the extra thing that can be changed over here in terms of the secant square theta minus 1. So we can do that then. So here secant square theta is as it is. Let's write that down. Plus the tangent square theta. Let me change that into secant square theta minus 1. So if you do that, you can see here everything is changed in terms of kind of secant theta, right? So if this is what you want on your problem, then I mean this is the another alternative. You could also write it down. So a couple of alternatives, but once you use the product rule correctly here at the first step, right, then actually then we are done. I mean this is the derivative, or I mean little bits combined form. I mean I would prefer this to be one of the like the derivative, but all of these will give you the derivative of the function wherever you want to evaluate. For whatever theta value you want to evaluate the derivative, right? All right.